Well, good morning, good afternoon. We've got folks joining us across the continent today. My name is Jesse. Welcome in on another exciting Exploring by the Seat of Your Pants broadcast. And if you're new to us today, like our speaker is, then Exploring by the Seat of Your Pants is all about bringing conservation, adventure, and science into classrooms around the world. Now, you're catching us on an exciting day. Number one, it's February, so it's our entire month solely dedicated to the most amazing women in science, exploration, technology all around the world. So you can catch all of our programs on our YouTube channel. We've had everything from cave divers to astronauts, archaeologists, and more. It's been an absolutely wild ride. February is always our biggest month, and we're so pleased you're joining us today to explore with some of the coolest people on planet Earth. The second reason today is exciting is because we are continuing our Changing Planet series number 2. Now, a few months back, we did this amazing collaboration in conjunction with Environment and Climate Change Canada. We have a Parks Canada program right after this. We've got all the government departments in Canada. It's very exciting. So Environment and Climate Change Canada is joining us again for an epic 5-part series with some of their scientists, technologists, and explorers across the country. Yesterday, we wrapped up with Elizabeth Jameson. She talked about water, tracking water all across Canada. And today, we are joining live with Lana Dolgova, who is going to track wildlife health coast to coast with us. She's a laboratory technologist for the National Wildlife Specimen Bank at Environment and Climate Change Canada. And her varied career has had her going to the lab, the field, very chilly walk-in freezers, and more. So we're going to learn a little bit about what that work is like, helping monitor the health of wildlife across the country. Without further ado, I'm going to stop talking about it. I'm going to turn you over to her. And Lana, thank you so much for joining us today. Welcome to the broadcast.
Hi, everybody. Oh, this is great. I'm so excited.
I'm so excited to have you. Yesterday, Elizabeth set the bar pretty high, but I think we're going to have a lot of fun. And if you want to dive in with your presentation, I know you've got a lot to share with us. Take us away, and we'll do this thing.
Yeah, I saw Elizabeth's presentation. It was fantastic. So I'm really excited to talk to you today. How's everything looking?
It looks fantastic. And I want to say it was so nice seeing you in the audience the other day on YouTube. So if anyone of our other speakers in the series are on YouTube and they want to chime in, we'd love to hear from you. But without further ado, you're in. It looks great. I'll leave you to it. Thank you so much again.
Awesome. Thanks, Jesse. So hello, everybody. My name is Lana, and I'm super excited to be here today with you talking about my job as a technician who supports different projects in wildlife health with Environment and Climate Change Canada. So let's take a look at the journey that I'll be taking you on today. First of all, I'll briefly talk about myself. Then we will talk about wildlife health. Next, I will kind of outline my job, and then we will put it all together and take a look at what a potential project in wildlife health at Environment and Climate Change Canada can look like. So for me, my love for the environment and for the animals started when I was very, very young. I remember going on a hike with my grandma through the woods, and all of a sudden we came across a construction site. They were building a house, and the workers were digging little holes in the ground to be able to put down the foundation. And when I took a look inside those holes, I could see that actually there were some frogs that were in those holes. They would accidentally fall into those holes and be unable to get out. And this is when I first started to realize that us humans, if we're not careful in our actions, we can have a negative impact on our environment and on the animals that live in there. So those types of experiences have really motivated me to want to study the environment and want to study sciences. So in high school, I took science courses. I took mathematics, chemistry, biology, physics to be able to continue studying sciences at the university level. And today I actually have 2 degrees in biology. I have a bachelor's degree from a university in Montreal, and I have a master's degree from a university in Ottawa. I have also had a great opportunity to work in Wildlife Rehabilitation Center in California. And this center really specialized in rescuing birds that were affected by different human activities. And those were usually either oil spills or irresponsible fishing. And I was surrounded by a lot of incredible, hardworking, and really passionate people who inspired me to want to continue working in the field of the of environment. So I went back home to Canada and I joined Environment and Climate Change Canada as a technician. And today I work at the National Wildlife Research Center in Ottawa. And a lot of my work supports different projects in wildlife health. So before I talk about my job, let's talk a little bit about what wildlife health. So what is it and how do we study it? So for us, when we think about health, we're typically thinking about long-term physical well-being of animals, right? But we're also interested in studying potential risks and potential threats that can occur to to their health. We're also not really focused on individual animals. We're more interested about the type of risks that we see in groups of animals, right? So it's a little bit like saying, we're not really interested in studying the health of Madison in grade 4, but instead we're interested in looking at health and health risks to all the kids ages 9 to 14 in Brampton, Ontario, for example, right? So we're kind of doing it at a larger scale. So what are some of these potential health risks that we're interested in looking at and studying? So this can be global warming, this can be habitat destruction, this can be invasive species, it can be pollution, parasites, disease. There's all sorts of different risks that affect different groups of animals. The team that I work for, we are focused on studying and researching contaminants in seabirds. So let's take a look at what that means. First of all, contaminants, right? What is that? Maybe by now you would have heard about molecules. And molecules are these tiny, 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 tiny building blocks that make up absolutely everything. They are the food that we eat. They are the air that we breathe. Our bodies are made up of molecules. Our clothes, our phones, absolutely everything is made up of molecules. Now, there's a small group of these molecules that exist in the environment, and we can't take them out of the environment. And these molecules can be absorbed by the bodies of animals, usually through the food that the animals are eating. And once the animals absorb these molecules, they also can't get rid of them. So that means that over their lifetime, they are accumulating and accumulating these molecules in their bodies. And at a certain point, if they reach a high enough concentration, these molecules can actually be detrimental and bad to their health because they have toxic properties. And these are the molecules that we call contaminants. And these are the molecules that we're keeping an eye on because of their toxic properties and the potential they have to harm our wildlife. Now, where are these contaminants coming from, right? So they're coming from all sorts of places. Some of these can be natural sources. So for example, a volcanic eruption or a forest fire. They can also be from different human activities. For example, a large factory that makes our clothes, for example, or the cars and the trucks that we drive. It could also be accidental, like an accidental oil spill or an accidental chemical spill, right? So these are different sources of these contaminants, and this is how they enter our environment. So now that we know what contaminants are, those small toxic molecules, what about seabirds? What are seabirds? And you guessed it, it's a type of bird. They are large birds, like this gull that we're seeing here. They're larger than your typical, sparrows or chickadees, and they live for a pretty long time, let's say 20 to 25 years. Also, as the name suggests, these birds spend most of their time on water. So not only are they excellent flyers because they're birds, they're also excellent at diving and swimming in the water. So also their bodies are actually adapted really well to this lifestyle. You can see this cormorant on the screen, for example. It has webbed feet, and that helps it move through the water. Seabirds are also predators, right? Bird as a predator. They eat fish, and these seabirds are actually found at the very, very top of their food chains. Seabirds also live in colonies, and some of these colonies can be absolutely huge, hundreds of thousands of birds. So it can get pretty noisy and pretty crowded on some of these colonies. So as a bird, you're really hoping for some good neighbors, right? And also, seabirds lay eggs once a year, and it will depend on the species, but typically between 1 to 5, 5 eggs. So why is it so important for us to study contaminants and seabirds together? Well, let's take a look at this ecosystem, right? There's a lake. Now let's introduce some contaminants into this ecosystem. Those are the little red dots that you're seeing at the bottom. Now let's imagine there are creatures, right? There's little bacteria, little invertebrates that live and feed at the bottom of this lake. And what's going to happen is their bodies are going to start absorbing some of those contaminants. And then let's say there's a little fish that feeds on these little invertebrates. They are going to start absorbing these contaminants as well. And then you're going to have a bigger fish that feeds on the smaller fish. And they're also going to start absorbing these contaminants through the food that they're eating. So what's important to note here is that at every step, the number of red dots that we see is actually increasing in our individuals. So the concentration of contaminants is increasing. Now, remember what I said about seabirds being at the very top of their food chain? Well, actually, what that means is these birds are going to accumulate the highest numbers of contaminants. Their bodies are going to have the largest number of those red dots, which means that these seabirds are the ones that are probably going to experience the most toxic effects of these contaminants, which is why it's so important for us to study seabirds and the effects that the contaminants are having on their health. It's also very important to note that a mama bird, when she lays her eggs, she's actually going to pass on some of the contaminants from her body into these eggs. So us in the scientific community, this is actually what we study. We study the number and the types of contaminants that we see in the eggs of seabirds, which is actually also very convenient because you can imagine trying to catch an adult bird that is just constantly going to be flying away from you versus trying to pick up an egg. An egg typically doesn't run away, so it's a lot easier to collect. In Environment and Climate Change Canada, we have actually been using the eggs of different colonial seabirds to track the contaminants across the country, from the Pacific to the Arctic to the Atlantic coast, in the Great Lakes, and also some large inland lakes like those found in northern Alberta. And some of our contaminant monitoring programs have actually been running since the late 1960s. So we have been collecting eggs for many, many years and looking at the contaminants in these ecosystems for many, many years to see if the contaminants are increasing, decreasing, or maybe staying stable. And hopefully when you look at this map, you think, wow, this is a lot of work. Who is doing all of this work? So let me introduce you to some of the people on our team. So we will have first our researcher, right? So this is our detective. This is the person who's really trying to answer the big questions about contaminants, about seabirds, and about how the contaminants affect the health of these seabirds. We also have technicians, and these are the people who work in the field and in the laboratories who assist the work of the researcher. We will also have specialists, and this can be someone like a chemist, for example, right, who is running an entire chemistry laboratory, whose job it is to actually detect the contaminants and their concentration in the seabird eggs that we collect from the field. And of course, nobody's working in isolation. This is very much a team effort, and we are all collaborating together to help answer these big questions. And this is where my job comes in. So I am a technician, and I work in different places. So let me take you through what my job looks like. First of all, I work in the field. So I actually get to go to these seabird colonies and do these egg collections. And these colonies are very isolated and they're very, very far. So we will need to take a plane, a boat, a helicopter just to get to these colonies. Once we get to the colony, we will do what we call an assessment. So we are going to walk around and see how many different species of seabirds we find on the colony. We're also going to count the number of nests that we see and how many eggs do we see in each nest. And because we're doing this every year, this helps us to look at the population of the birds in this colony to make sure the numbers aren't dramatically decreasing or increasing. The next step for us would be to actually start collecting these eggs. So we're walking around and we're taking one egg from a nest until we have about 10 to 15 eggs collected per species. And of course, while we're doing all of this work, you can see the birds in the background there. They are very unhappy that we're there. They will absolutely swoop down and hit us with their feet. They will poop on us. They are constantly screaming at us. They do not want us there, which is why it is our job to move as quickly as possible so that we're not stressing these birds out. It's also important to note that if we take one egg from a nest, this will not have any negative consequences on the population size of these colonies. And we also have all the right permits and documentation in place that allows us to do this type of work on these colonies. So once we have collected the necessary number of eggs, we put them in these hard shell cases and we bring them with us to Ottawa into our lab, where my job now as a laboratory technologist continues. So what I will do is that I will take the eggs that we have collected in the field, I will wash them very, very well. I will then very carefully open the eggs up and take all the egg contents out. I will then mix the egg contents really, really, really well and pour them into different containers that you see on the bottom right of the screen there. And the reason why we have different containers is because it depends on the different type of chemical analysis that we're going to be doing. So some of these containers are going to go to our chemists, and the rest of them will go into our specimen bank, which I will talk about in a second. So it's also very important for us when we work in the lab to keep our space very, very clean. And this is because when we work with contaminants, we want to be sure that we're not accidentally introducing a different contaminant, a new contaminant that wasn't there, right? So as laboratory technicians, it's very important that we clean our spaces before and after our work. So one more time, I'll be sending some of these containers out to our chemistry lab, and the rest of them will go into the specimen bank. And the specimen bank, it's basically 3 large walk-in freezers. And when I say freezers, I mean freezers. It gets down to minus 40 degrees Celsius in there. So anybody who works in those freezers, they need to make sure to dress really, really well so that they stay warm and safe when they do their work there. And remember when I said that we were doing these monitoring, these egg collection since the 1960s, and we do them every year. So you can imagine that we have quite a large collection of eggs and also different types of samples in our specimen bank. So by now, we have learned about a lot of different things. We learned about the contaminants and how they are these little toxic molecules. We talked about seabirds and how the contaminants find their way inside the seabirds. We talked about how eggs are important to our science community. We talked about how as technologists, we are able to transfer the eggs from the field through the laboratory and then send them off for chemical analysis. Now let's put all of these different ideas together and take a look at what a potential project in wildlife health at Environment and Climate Change Canada may look like. So imagine there is this ecosystem and there's different wildlife that lives in it. Now let's introduce something new. Let's build a power plant. Let's say it's an electric power plant, right? That produces electricity that we all need and that we all use every single day. And because now something has changed in this environment, it's very likely that the types of molecules and their numbers are going to change as well, which is fine. Our researcher is interested to knowing specifically, are we also seeing an increase in contaminants in this area? How are these contaminants moving in the environment? Is it through the air? Is it through the water? Are these contaminants being absorbed by the wildlife that lives there? And if it is being absorbed, what are the concentrations that we're seeing? And what are some of the health effects that those contaminants can have on the wildlife that lives in this area? So these are all the questions that our researcher is very interested in answering. And she will give herself maybe 5 to 10 years to actually address those questions. And those 5 to 10 years will be of constant egg collections and of constant experiments. Now, let's say she is a bird biologist, so she will select a species of seabird that she is interested in doing research on. She will send out her team of field technologists who will do these egg collections. They will then bring the eggs with them to the laboratory, where the lab technicians are now going to take a closer look at the eggs. They're going to take out the egg contents, mix it really well, and then put it in different containers. A chemist now is going to take a look at what's inside that container and tell us, are they seeing contaminants? What types of contaminants and what are the concentrations? And then these egg collection and these experiments, these analyses, they're going to be repeated every year for, again, 5 to 10 years. And then we're going to be able to tell, are we seeing an increase in contaminants in the environment? Is it a decrease in environments, or is it going to stay the same? And once our researcher kind of looked at all of this information, they're going to publish a report. They're going to publish their findings in a journal. And that way they're able to share their information with other scientists, with policymakers, and with the public. So this is kind of an overview of what a potential project could look like. So by now you're probably thinking, Lana, this is the best presentation I have ever seen, but I'm not a technician yet. I'm not a researcher yet. Maybe I don't really care about sciences, but I love the environment and I love the animals that live in it. Is there anything that I can do? And let me tell you, anything that I do in my daily job, you can do as well, no matter where you are. So let's take a look at some of the things that you can do. The first is to act small. So obviously none of us have these big factories, and none of us are going around dumping buckets of contaminants into the waters, or at least I hope not. But we can still have a negative impact on our environment. We can still introduce contaminants into our environment. For example, if you go on a hike and you happen to have garbage on you, are you just going to throw that garbage onto the grass, or are you going to keep it with you and dispose of it later on? Also, if you come across wildlife, how do you react? What's your reaction? Are you going to be running up to them, trying to take a picture, or are you going to observe them from a safe distance, right? So even small acts that we can take will have a big impact on our environment and the animals that live in it. The second is to look for changes. And this is something that we do in our jobs, right? So just observe the environment around you. Are you seeing the same birds every year? Are you seeing the same insects every year? And if yes, what about their numbers? This might mean that you will need to learn the names of the birds and the insects and the trees that you see in your area. But I find that being able to identify things but by their names is super, super fun. And the last thing that you can do, and this is what I'm doing right now, is just talk about it. So talk about the environment, talk about environmental health to your classmates, to your friends, your teachers, your family, your neighbors, and ask them questions. What do they think a healthy environment looks like? What does it feel like? What does it smell like? What does it taste like, right? What is a healthy environment? And if you're talking to somebody who's a bit older, you can ask them what their environment looked like 10, 30 years ago, right? And then compare it to what your environment looks like now. And together you can maybe even talk about what you want your environment to look like in the future. And with that, I would like to thank you very much. And I will take any questions. Thanks.
I like the excited bird spin at the end as well. That's
Yeah.
fantastic. Well, if you want to come out of screen share, see me again, we'll have our conversation. Thank you so much for that. What a deep dive. And that was some slick graphic artistry stuff going on. So Environment Climate Change Canada, you guys are killing it. That's amazing.
Thanks.
We've got so many questions that have come in. So a lot of places to take this. First and foremost, again, thank you for sort of an overview of your early career. There's some really cool stuff on the go. What an interesting job. We got a question, and I knew we were going to get this, about the bird eggs, because the idea of, we talk a lot about conservation biology and saving individual animals, and here you are going and you're taking eggs away from birds out in the field. Is there another way of doing this? What's the impact of taking these eggs? Anything you can share about that would be fantastic.
Yeah, that's a great question. So actually, I briefly mentioned it, but taking an egg from a nest that has a full clutch, meaning usually, let's say if a species of birds typically lays 3 eggs, we will only ever take an egg if it's a complete 3-egg clutch. Yeah. And if we take them early on in the season, which is something that we aim to do, a lot of the species, they will actually relay the egg. So if they're expected to have 3 eggs in their laying season and we take 1 away, the bird will lay that 3rd egg. So there's actually, at population level, there will be no effect if we take those eggs away from them.
Fantastic. You did mention, but I want to harp on those moments when we get them for our questions. So thank you for that question, guys. Is there a favorite place to work? We get this in almost every broadcast. Is there a place that you've been that really jumps out? Like, okay, coolest thing. Could be a lab, could be the field, anywhere that really shines through.
Yeah, no, that's a great question. And I think for a lot of people who work in sciences, we always look forward to the field season, right? So that's when we actually get out there, get to interact with nature and have these firsthand experiences. So definitely in the field, I will say that the favorite place that I've been to, and I'm very lucky to have gone there several times, is the Peace Athabasca Delta. And this is in northern Alberta. And we usually will take a helicopter to the colony. So we're flying over this fantastic boreal delta, and it's just so, so beautiful and so isolated. Very few people get to see it. So this is definitely my favorite place for sure.
You're the first person to ever mention that specific part of the world, so I really encourage our class to check it out. And one thing that's kind of nice about Canada is that, like, so I grew up in Toronto, so I'm surrounded by people. When I thought about wildernesses, I thought about Australia and East Africa and, Bora Bora. And Canada is mostly wilderness. Like 95% of this country has almost no one. I live in Western Newfoundland now, where the population density is like Western Sahara or the Mongolian desert. And like Northern Alberta is wildly empty, and you have this capacity to experience these incredible just agglomerations of wildlife. So lucky you for having that chance. And I love, one of the joys of this job is that I get to have scientists on and technologists who come in and talk about the fact that, like, field season, like, yes, I want to be pecked by giant birds while I'm taking them. With Elizabeth yesterday, yes, I want to go out in the frozen river and life and limb to get that data. That's your sign. You're a scientist. If you are a student and you enjoy those things, this might be a cool career for you. Is there a timeline of how long this has been going on for? Yesterday we talked about over 100 years they've been monitoring water. Is there a sense of how long we've been monitoring these contaminants, and how long have you been doing it?
Yeah. So remember from the map, it had different gold stars kind of all over the place. And the timeline is going to be different depending of where we're doing our work. But one of our oldest contaminant programs has been started in the Great Lakes, and it has been running since the 1960s. So you can imagine we've been doing this work for a very, very long time. Myself personally, I got involved with Environment and Climate Change Canada 8 years ago now. So it's been quite a ride, and it's been very, very fun.
may you be in till 2060, and then we can look back and it'll be 100 years by that point. Very
That's
cool.
right.
And I'm so glad you mentioned the Great Lakes. Honestly, I want to harp on this for a second because I grew up on a Great Lake, and like to me, it was just like the lake. But like these are some of the most incredible bodies of water in the world. All the more so because tens of millions of people live on the Great Lakes, but there's still a habitat for wildlife, and it's so important that we monitor these sorts of things. So I'm glad you highlighted this, and it leads me nicely into something that we talked about in September. So September is Plastic We Are Month, all about ocean plastics. We talk about it all the time. Is plastic one of the contaminants you're looking for? Is it just molecules? Can you speak a little more to that? And do we find any sort of, is there like a peak contaminant that we should be on the lookout for and are, I don't know, as the public?
Yeah, great question. So for in terms of the plastics, we are definitely looking at plastics, and these can be addressed in different ways, right? So we can talk about big pieces of plastic and an effect that they can have on wildlife is, for example, you may have seen this, right? Like birds getting stuck in plastic, or if they ingest those big pieces of plastic, then their bellies feel really full, but they don't really want to go out fishing because they feel full, but they're actually getting absolutely no nutrition from the plastics. In terms of the contaminants, I think this is when we can talk about microplastics, right? So once plastics are broken down to tiny, tiny little pieces, and they might get absorbed into the tissues of animals, then it kind of becomes a contaminant, the way that we talk about it. And these are definitely things that we're doing and that we're looking at in seabirds in different places in Canada. In terms of contaminants in general, in Canada, we're doing a fantastic job at actually making sure that the contaminants that we're seeing in wildlife, that we keep the levels as low as possible. However, it's very important for us to realize that these contaminants, they can move very, very long distances. We have absolutely seen contaminants that can cross entire oceans, right? So even if we're doing everything that we can in Canada, it's possible for contaminants from far away, like from different countries, making their way to Canada. So it's very much an international effort, and we need to really collaborate with everybody on an international scale.
Well, and it's one of those things too that sort of it's a great topic for discussion and collaboration because it's one of those like universal, like there's no politics behind it. No one wants contaminants in the water. Like no one wants contaminants in the environment. No one wants those things. We've seen the impact of them. And I mean, the Great Lakes is another perfect test case because Canada and the US share the Great Lakes. And so you have these two major world powers that are working to collaboratively work to make sure that we don't have these things, impacting our wildlife. So I'm really glad you highlighted all that.
Yeah.
Is there, how are we doing? Sorry, weird segue. How are we doing in terms of contaminants in the environment generally? Are there more than there used to be? Are there less? We've got, many decades of data now. Are there some that are going up and down? And can we trace sort of how that came to be? Any insight?
So when we say contaminants, and when I talked about contaminants, I'm using the term very broadly. We need to realize that inside this word contaminants, there's a lot of different types, right? And some of these contaminants, for example, have been produced by humans a very long time ago, and then we realized, whoops, like they're really bad for the environment, we need to stop. But they kind of still persist in the environment. So even though we stopped producing them, we're still finding them in the environment, and we can't take them out. There's also different types of contaminants that we in Canada, for example, are doing a great job at controlling, because if they are coming from human sources, we can actually put, regulations in place, or improve our technology that kind of limits the amount of contaminants that enter these ecosystem. But we also need to realize that every year we also produce new contaminants, right?
Yes.
So this is what we call emerging contaminants. And it can be, which is why it's so important for us to monitor these places every single year, because it's possible that we are going to start finding new contaminants, right? Because, we produce different chemicals, for example, right, for different commercial purposes. And some of them can accidentally find their way into our environment. So it's very important for us to keep monitoring every year so that we're able to detect some of these contaminants and also their concentrations in the environment.
I'm so glad I live in a country that is so diligent about these things because, as
Yeah.
I said to Elizabeth the other day, like I've been to places where this is not the case. Open pit sewers. There's you can literally drive by the roadside and these things leaking into the water supply, and we don't have that here. Because if you do that, you face fines and penalties, and they clean that up immediately, and that's really important. Like I can drink water from the tap. I have clean air when I go out. Wildlife is by and large healthy. Those things are really, really important. So thank you for sharing all this. By the way, on the note of regulation leading to contaminants being taken out of the environment, I really encourage our classes. CFCs and leaded gasoline are two amazing examples of international collaboration to remove a contaminant from the environment that was going to have really major negative impacts, or was having really major negative impacts on the environment or on human health. So those are two test cases that are just awesome. Learn more. It could be 10 broadcasts in and of themselves just covering those two, but it's a neat follow-up to this story. Is there a bird or species that sort of takes in the most contaminants? Is there one that you're like, oh, they're full of it, that you can share?
Yeah. So again, we are really focused on looking at the animals that are feeding at the very, very top of the food chain. So these can be seabirds. These also can be river otters. These can be polar bears, right? So any kind of like predators that eat lower on the food chain, they are going to be the ones that are absorbing the most of these contaminants. And those are the ones that we want to keep an eye on. There's also certain animals that, for example, are hunted for food, right? So we're very interested to know what are the levels of contaminants in the tissues of these animals, so that any person that will eat this food, they will feel comfortable eating it.
I'm so glad you mentioned that. I almost gave it away in the last question when I stopped myself. But like in Newfoundland, where I live now, hunting is a huge part of the culture here. Like people go and hunt moose every single year. Fishing is like the essence of the entire province. And so does Environment Climate Change Canada solely sort of mitigate those harms, or do you work with Health Canada or anyone else to make sure that the food that we're eating isn't full of contaminants? Like who deals with that? I'm curious if you know.
Yeah, absolutely. So this is definitely very much a team effort. So anytime that we look at animals that are used as food by people, we will absolutely collaborate with Health Canada, because anybody who works for Environment and Climate Change Canada, we are really focused on the natural environment, the animals. But once we start involving humans, this is already becoming Health Canada. So there's definitely a lot of collaboration between the two teams, but anything really human related is going to be with Health Canada.
Very cool. We've had them on too, by the way. We've had all the departments. It's been very fun getting to feature Canada's greatest scientists and explorers in broadcast over the last 8 years. Lana, time flies and you're having fun, and we're nearing the end of the broadcast. So I want to
like a bird.
Thank you very much for that in my day. Professional detachment out the window. That was magnificent. And you're the first person in 3,000 programs to ever do that when I say that. So thank you. As a final question to wrap us up, how can our kids help prevent contaminants from getting into the environment at all? Is there anything that you'd recommend? And this can be in your professional capacity, personal capacity, anything you want to leave our kids with on like making sure the environment's a little bit healthier and cleaner.
Yeah, so we definitely talked about, being very careful about how we dispose of garbage, right? So just be very mindful about not leaving it behind. If you are, enjoying the environment, make sure to bring it with you, dispose of it correctly. Also, for example, take, if it's possible and it's accessible to you, take a bike instead of taking the car with your parents, right? Or take the bus instead of taking the car. And also just keep in mind that even though right now we're obviously talking about sciences and, don't think that the only way that you can help the environment is through pursuit of sciences, right? If it's not for you, that's okay. Maybe you want to make a really cool movie about the environment, right? And that's cool too. Or maybe you want to write a poem or whatever. Like there's so many different ways in which you can still help the environment if science is maybe not your thing.
Those are beautiful answers. And I mean, the nice thing is that a lot of our kids know those individual tangible solutions, prevent your greenhouse gases from getting into the environment, don't produce waste, make sure your waste goes to the right place. Like kids are imbued with that knowledge now in a way that, our generation, like we're doing pretty well. Kids that are under 16 are like doing amazingly. Like you guys rock, which is great. But I love this note. And this is something that we hear in a lot of our programs nowadays. Like if you don't want to be a scientist, that's fine. I think it's an amazing career. I'm a scientist by background. Getting to do this stuff is incredible. And you've heard the passion from Lana today. So there's lots of opportunities to be had. But whatever your interest, like the key to these broadcasts is just to showcase that science is an amazing way of approaching the world, of solving problems, of being curious and taking that into make it, have a positive good in the world. So that can be something that you do regardless of what your career path might be. And I really thank you for sharing that with us today, Lana. This has been so much fun. We're nearing the end, so I'm going to note again, if people want to check out the whole series, this is just day 2 of 5. We've got like 3 other programs to come. Elizabeth's on YouTube. Everything's on YouTube. So you can share this with your family and friends. Lots of opportunity to keep the learning going. We're going to email all our registered classes too, with all sorts of amazing stuff that Environment and Climate Change Canada has on the go. But before we wrap up, I just want to say again, thank you so much for joining us, and we really appreciate your time today. This was magnificent.
Thank you so much. This was a great time. Thank you.
We'll have to have you back, but for now, we'll say farewell.